Hello everyone, welcome to Newton Nuts Physics. In this video, we are going to solve question 7 from the Edexcel International GCSE Physics November 2024 paper. This question tests your understanding of forces in fluids, upthrust, equilibrium and pressure in liquids. So let's work through it step by step. The diagram shows a submarine at rest underwater. So this submarine is at rest means it is in equilibrium and the resultant force should be zero. So I'll note down that one here. There are two vertical forces acting on the submarine. One of the forces is called upthrust. Give the name of the other force. Yeah, so we'll see what is meant by upthrust first. Actually, when an object is fully or partially immersed in a fluid, an upward force is given by the fluid on the object. So that is the upthrust. So upthrust always acts in the upward direction. So since since the resultant force is zero, definitely the other force should be in the downward direction. No? So definitely the other force should be the weight. So basically, weight means the gravitational force acting on the object. Yeah, we'll move to the next part of the question. Draw two arrows on the diagram to represent the vertical forces acting on the submarine. Yeah, so right, one vertical force is the weight. So you know that weight acts vertically downward and that acts from the center of gravity of this submarine. So we can represent the weight by drawing a downward arrow like this. So the other vertical force is the upthrust, no, and you know that the upthrust acts vertically upward, and we can represent upthrust with the vertical upward arrow like this. The other thing you have to consider when you are drawing this diagram is like this. So you know that the resultant force here is zero, no. Since the resultant force is zero, upthrust should be equal to the weight. Therefore, the size of these two arrows should be equal. That means the lengths of these two arrows should be equal. Next, we'll move to the next part of the question. State the formula linking pressure, density, gravitational field strength, and height. Yeah. So then, actually, this equation is based on liquid pressure. So we shall write down the equation. So the pressure is equal to height times density times gravitational field strength. Yeah, for your additional knowledge, I'll write down the equation with symbols also. So P is equal to H rho G. This is the equation. So we'll move to the next part of the same question. Calculate the pressure from the water at a point 38 meters below the surface of the water. Density of seawater is given as 1030 kilogram per cubic meter. So we shall go with the question. So we have to use the previous equation we have derived. So that is P is equal to H rho G, or pressure is equal to height times density times gravitational acceleration. So you have to find the pressure here. Height from the liquid surface is 38 meters and density of seawater is 1030, and we are using the gravitational acceleration as 10 meter per second square. So we'll calculate the answer with the calculator. So the answer comes as, when you solve with the calculator, the answer comes as 391,400 Pascal. So in discussion, they are asking us to keep the answer in kilopascal. So when you are converting this pressure into kilopascals, you have to divide this value with 1000. So that means 391.4 kilopascal. This is the final answer. Yeah, we'll move to the next part of the question. To rise back to the surface, air is pumped into the storage tank inside the submarine. Explain how the air exerts a pressure on the walls of the storage tank. Yeah, we'll go with that question. So they are saying that there is a storage tank inside the submarine and air is pumped into it. And in that case, these air particles collide with the wall of the container, wall of the tank. In that case, the air particles exert a force on the wall of the tank, and you know that pressure is equal to the force over area. No? So then, when air particles exert a force over an area of the wall of the tank, the pressure is created. Yeah, I think you understood how the pressure is created there. So we'll write down a proper answer for this question. Air particles collide on the wall of the storage tank. Air particles exert a pressure on the tank. Force applied over an area gives the pressure. So I think you understood that one clearly. Yeah, so we'll move to the last part of the question. The air in the storage tank starts at a pressure of 410 kilopascal. As the submarine rises, the air in the storage tank increases in temperature from 2.5 degrees Celsius to 18 degrees Celsius. The volume of the storage tank remains constant. Calculate the pressure of air in the storage tank at 18 degrees Celsius. Yeah, so then, like in the previous questions, before doing this one, we shall sketch a diagram. So, at the beginning, the pressure is 410 kilopascal, and the temperature is 2.5 degrees Celsius, and then the submarine rises, and during this process the volume does not change, volume is constant. So the final temperature of this gas is 18 degrees Celsius, and you ask in the final pressure. Basically, according to the data given in the question, we have to apply the pressure law here. So that means when you apply the pressure law into two instances, so we can apply it as P1 over T1 is equal to P2 over T2. And in this case, definitely the temperature should be in Kelvin. So they have given the temperatures in Celsius, no? First, we'll convert these temperatures into Kelvin. So 18 degrees Celsius. So when converting Celsius temperatures into Kelvin, you have to add 273 into the Celsius value. 18 plus 273. So the answer is 291 Kelvin. And next we'll convert 2.5 degrees Celsius into Kelvin. That is 2.5 plus 273. That is 275.5 Kelvin. So I'll note down the temperatures here. So here in the second instance, the final temperature is 291 Kelvin, and in the initial instance, the temperature is 275.5 Kelvin. Yeah, so then we shall apply the values into this equation and get the final answer. In the first instance, the pressure is 410 kilopascal. So actually, it is not essential to convert this pressure into kilopascal because we are considering a ratio here. So in this case, the final answer also comes in kilopascal if you keep the pressure in the first instance as kilopascal. So we shall keep that one in the unit kilopascal. So in the first instance, the temperature is 275.5. Sorry, 275.5 Kelvin. We have to find the pressure in the second instance, and there the temperature is 291 Kelvin. So we shall find out the pressure in the second instance. So that is 410 kilopascal times 291 Kelvin divided by 275.5 Kelvin. So the pressure in the second instance is 433 kilopascal. This is the final answer. So I think you understood this one clearly. So this is the end of that question, and see you in the next video.
If this video made that light bulb go off in your head, do me a quick favor. Smash that like button and subscribe to the Newton Nuts channel. It really helps me keep creating these free lessons for you. Now, if you want to completely ace your upcoming exams and need a little extra support, I've got something special for you. Head over to www.newtonnuts.com right now. To make sure we are a perfect fit for your learning style, every single student gets a 30-minute, one-to-one free trial class before we officially begin. No strings attached, just 30 minutes of dedicated, personal physics help to kickstart your progress. Thanks for tuning in today. If you enjoyed this lesson, stay tuned. I'll see you in the next video with more exciting topics.